Hi all, this is BRR. In this video session, we'll talk about value types and reference types in C#. So, as we discussed in the earlier session, so there are a lot of built-in data types. So, in those built-in data types, we have value type data types and reference type data types. But first of all, what is a value type and what is a reference type? So, as I told you, data type is a value type if it holds the data value within its own memory space. It means variables of these data types directly contains their values. So I can say value type is nothing but kind of data type which holds data value with its own memory. It means variables of these data types directly access the values, and because it contains the values directly in the memory. So for example, and like if you say like int I equal to 100, that means the system stores 100 value in the memory space allocated for the variable I, and the following diagram will illustrate if you can look at here. So in the value type, if I store a value is like int I equal to 100, the 100 value is being stored in the memory like this, and it allocates some address for this, and it is putting on the RAM. So if you look at this diagram, the 100 how it is stored at some hypothetical location in the memory, like this 0x239110 for I. All the value types derive from system.value type, which in turn derives from system.object. So based on this address, you can access this value. Like if you look at in programming part in C language, we'll be using ampersand that represents an address. So if I use ampersand I, that is going to get the address of the I variable, and with that address we'll be getting the value directly from the memory. So variables that are based on value types directly contains the values. Assigning one value type variable to another copies the contained value. So this is what the value type. This value type, how we are going to pass a values, like when you pass a value type variable from one method to another method, the system creates a separate copy of variable in another method so that the value get changed, and then one method won't affect on a variable in another method. So like I have a function this function where I will be defining one method here, public void print. I'm passing I variable here, and I'm changing this to 200, and then I'm printing console.write of I. Okay, so this variable I'm declaring it here int like simple int I equal to 100. I'm calling this print method. I think better it can be inside of this. Okay, program dot, or I can create a class. Program class obj equal to new program. So now I can access print method of I. So what it will be doing here, I will be having 100 initially this I variable, and I'm printing this console.writeln. Console.writeln of initial value. Okay. So after this initial value, I'm calling this print method by passing a value like I. So this I value here I've been changing here, and again I'm printing in this function. But remember, this value will not affect this original value. Original will always 100 only. So this is what passed by value. But when you pass a reference, by reference, a kind of thing, what it will do is it will pass the address. So unlike value type, reference type does not store its value directly. That's why the reason it can be changed. It stores the address where the value is being stored, and in other words, we can say a reference type contains a pointer to another memory location that holds data. So if you send a value like this way using a byref attribute, like I say, like this is declaring as byref something. So the address I'm sending it here. So must be passed ref keyword. Okay. So I'm passing a reference of my I variable here, and when I change the value, it is definitely impacting this value. Like, you know, this is my initial value, and if I print this, you know, after value something, after print function value, I will be getting 200 here because I'm passing address. That means reference. By default, it is a value type, and when you pass this thing, it will pass reference. Okay, so we'll see how it is working now. Initial value console dot read key, so that it will wait for a key to suppress the line of thing. And this is something, and here I'm printing value like, you know, I value from print function. Okay, now if I run this program, and if you look at here, it is coming here, it is printing I value as, you know, 100 here, and it is asking for enter key press. I pressed some key, and it is goes back, and I'm just calling it print function here, and go to this print function, and this value is carrying 100, and I'm changing this value to 200, and I'm printing 200, and now 200 value has been printed here. Initially 100, in the print function 200 has been printed, and again I'm going back, and here if you look at this particular variable, I'll be having 200. Wow, because I'm passing a reference to my function but not value type. So that is why the change value is impacting the original value. That's why byref always maintain one copy. It's not maintain separate copy. So it maintains one copy because we are directly accessing address of your variable. So whatever value you are changing in different functions, that definitely impacting or reflecting the original value. So that's why it is giving initial value 100, and the print function I'm printing 200 after change. Again, I'm going back and printing original value. It still holds 200 but not 100 because the value being changed with the ref keyword. Okay, this way the byref is working out in this context. Okay, now coming to the value types, these are the data types which give you a value type. You know, these scenarios: bool, byte, char, decimal, double, enum, float, int long, byte, short, structure, uint, ulong, ushort. These are the value type data types. That means these are storing directly values, but not you know, the it depends on the address kind of thing. When you convert one value to another value, that is boxing, unboxing kind of thing. So we'll be basically looking at this value type and reference type. Value type, basically what it will do, it will directly stores the value. Okay, and coming to the reference type, as I told you, reference type is a data type that refers to an object in memory. Like if you say this is hello world as an example, I'm storing in this value, it is storing address instead of value, and again value is storing here in the RAM. So it has two entries here. In the one thing is an address, one thing is in value, and we are always referring the address. Address again referring the value type. This is the value type scenario. This is the reference type scenario. And value type we are always directly getting the value, but in reference type we'll be getting address first, and with that address we'll be getting a value. Okay, I hope you got the point. So if you look at the reference value type, you're directly having a value in the I, you can directly access it. But when it comes to reference type, it stores the value in the value type. But this reference type address is again storing in other location in the memory, which it called as a reference, and it has another address. Okay, two addresses it has in the reference type. So it is always, very hectic job where the converting one reference type to another reference type, or accessing of a reference type in the programming language, because it has two entries in the memory. One thing is an address, and again address is depending on the actual value which being stored on the RAM area. Okay, so what are all the different data types comes under reference type? Basically, string is comes under reference type. All arrays, even if their elements are value types, class, delegates, these are comes under reference type. Because if you declare a variable with these data types, it is going to create two entries. One is a reference entry which holds address, and one another entry is the actual value which related to the address. Okay, so this way the value type and reference type is behaving in the programming stack flow or memory flow. When you compile, it looks for, let us take I have been declared a variable and using with reference type, like I have been declared a string variable, like let us say like hello world. So how it is going to fetch the value at runtime? So first it looks for address and it fetch the address value, and then it fetch the actual value based on the address. So this way, two things happening in this reference type. So always value type is very faster, and reference type is a little bit slow because it has two rounds, two process. Okay. So what are the points you need to note here is value type stores the value in its memory space, whereas reference type stores the address of the value where it is stored. Okay, primitive data types and the structure or of the value type. As I told you, these are the primitive data types. So these are the value type data types, and class, object, and string, array, delegates, and reference kind of things are related to reference types. Value type passes by val by default, so no need of specifying it here. If you look at program which we have seen here, so no need of using passing of value, because if I'm not using this reference keyword, by default it says that it's a by val. Okay, if you want to keep a function which should accept a reference value, you need to use a ref keyword. Okay, value types and reference types stored in a stack on heap memory. In the memory depends on the scope of the variable. So stack and heap memories they are using. Value types are storing in stack memory, and reference types are storing in heap memory. And again, heap memory is depending on the stack memory where it has actual value. So this way the memory is occupying and giving you for your programming variables. Hope you understand what is value type and what is reference type. And while you at runtime, when you are running your programs, how the value types are fetching the value from the RAM, and that is the stack memory, and how the reference types values are coming out from the heap to stack. Okay, thanks for listening to this video, and please subscribe this YouTube channel for more videos on C#. Thank you.